Okay, so we're gonna get started today with the last point that we still had to discuss a little bit. It's not complex, but we still have to cover that, which is a point about inheritance, and it's a keyword called sealed. And I promise this is the last slide of today of topics, new topics. Sealed. Sealed is a keyword that when you apply that to a class, it means that this class cannot be inherited from. Okay, so again, if you apply the sealed keyword to a class, no class can inherit from that. Now, I think that what would be a natural question about that? Anyone would have a question about that? Again, you cannot, if you say that a class is sealed, you cannot inherit from it. And what, at least from my standpoint, there's a question that naturally would come up. Why we would use it? Why? I mean, what's the point of making a class not inheritable? Okay? So again, when you do this, the class cannot be inherited from. It cannot be the parent of any other class. There are actually two reasons that I can see that someone would want to do that. Well, in a way, you are protecting that class. You are protecting that class from someone further extending that. Maybe you have a commercial product, a commercial library. Maybe you have a commercial library, a commercial product that you want people out there to use, but you don't necessarily want people to extend that. And whenever we create a child of a class, it's almost like we are wrapping that class inside of our own class. So again, a commercial product that would allow you to do that, maybe it's not in their best interest to allow you to further extend their private code, That's one. The next one is that when you have this concept of inheritance, it creates some overheads to the computer, to the application. Because, see, any class that is not flagged as sealed, the processor, C#, the framework, it needs to figure out if it has children. It needs to do those extra steps necessary to see, oh, does that class has children or not? Do I need to care about that? That creates a little bit more processing from the part of the application, from the part of the computer. So if you are working in an application that needs to perform very well, you may want to seal your classes if you don't intend to expand them. Because you are reducing a little bit, not much, but a little bit the processing time. And if performance is a key factor for your application, for your system, maybe you seal the classes that you will not be extending at all. So that's the second reason why you use that. Okay? So again, the last new thing for these 2 weeks of inheritance, polymorphism, abstract classes, interfaces. Again, just a general recap here. So abstract classes can not have concrete objects from it. Concrete classes can, of course, because it's a concrete class. Abstract classes can have abstract methods, which have no body, no statements, and can have concrete methods as well. Interfaces, on the other hand, it can only have abstract methods and abstract members. It cannot have implemented members. A class can only inherit from one single, either concrete or abstract class. So any class can only inherit from one. However, any class can implement multiple interfaces. Okay? So, we are sealing our knowledge with sealed. Anyway, let's see here. Any question about sealed? Aside from the question of why is it for, I mean, what is it used for? Because
So
I've tried to explain a little bit.
If we seal the last child class, because we're not going to use it, nothing else.
Yeah, it could be.
Like
You can seal that.
All the child classes at the end.
You could do that. You cannot seal its parent, because if you seal the parent, then again the child cannot exist. Okay. Awesome. Let's do a few things here. Okay. One thing that I wanted to mention here on Centennial is that for week 9, the exercise about. Let me see if this is. Yeah. So for week 9, you have the you do it yourself here. I have a solution here. So solution files are here. Programming exercise, the programming exercise 8, the solutions are here, all of them. And you can also find this link here for a commentary of point by point by point. So it's a YouTube playlist that you're going to see. Each one. So you do it 1, 2, 3, exercise 1 part. Exercise 1 just has one part. Then we have exercise 2, 3, and 4. So again, I went code by code and I made my comments there. All the explanation is there. If you want to try to do it yourself, you can do it, and then you can compare with the code solutions and with the videos as well, because the videos, again, will explain why this was done, not that. Okay, so again, just want to remind you of where you can find that. I'll always, after each week, I may not remember to mention that, but I'll always post the solutions here in Centennial, and I'll try to post videos about the solutions as well. So again, you can refer back to Centennial, to the corresponding week, and see the solutions, and hopefully see some video solutions as well, okay? Again, just a quick reminder. Okay, now, I have planned something. We're going to go through our exercise. I have planned something a little bit different today. Let's see. Okay, we're going to divide groups here. Okay, so I think that we have the 4 of you, the 3 of you, and then the 3 of you, and then the 3 of you, and then the 3 of you. And again, let's just go row by row. It's just 2 over there, so let's do 3 of you, you 4, and then you 3 there. Okay? Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8 groups. Okay, that's the biggest one. Let's see how this goes. So we're gonna do this. We're gonna have a bunch of words here. Let's see where. Actually, I uploaded that to Centennial. So if you go to week 10, and there is something called activity there. It's a PDF. You're going to see a bunch of words there. Actually, I think it's 19 words there. We're going to do this. We're going to get those 19 words. You're going to create diagrams. You're going to create maybe 1 UML diagram with everything, maybe 2, maybe 3, maybe 4, maybe 5. I don't know. But you're going to look at those words there, 19 words, 19 or 18, I think 19. You're going to write that down in a Post-it note, and you're going to paste on your corresponding spots over there. You're going to build a tree of how you understand that this could be mapped out as a hierarchy of classes and objects there. So again, each Post-it note will have 1 word, and then if you put a Post-it note like this, it means that this is the parent of this, this and this, this is the parent of this, and it goes on. Again, you can interpret the words the way you want. There is my way of interpreting it, but I want to see your way. So the first part of what we're going to be doing is I'm going to distribute those. I'm going to distribute these. Let's see. Here we go. And whatever is left, I'll need whatever is left back. The plastic, you can give me the plastic. I don't know if there is garbage here. I don't know. But the plastic, I can throw the plastic bag out. So you can do the three of you. Okay. The four of you and the three of you. I went cheap there. I didn't go Post-it notes, and I went the cheaper brand, but it should work. I hope it sticks. It promises that it sticks.
Is one word for
Each. So again, one word for each note, and then you build a tree. And then what you can do, you can use that wall, you can use that. The three of you can use that wall. And then the three of you, maybe you can do it here. And then the three of you can do it here. And the three of you can do there. And the three of you can do maybe here. Whatever makes it easier. But again, make it visible. Oh, and I have a, just to make it, just so you can highlight this better. Here it goes. 14. Roma. Here. It's a bit stronger so you can see it better. Guys, here. You can join this team. What's up? I think got this, so don't get garbage here. What's up? Each card, you put one word, and then you're going to create a diagram of objects, of classes. It might be one single diagram, one single pyramid. It might be two. It might be three. Use your imagination there. Look at the words and create however you are able to visualize this order.
You have to write each one
in one single. So
okay.
Again, each single word in a separate sticky note, and then you create a hierarchy. It might be one, it might be two, three, four, how many you see fit. Okay? The garbage here. Yes.
So we're almost done.
Okay, no problem.
But it's only for the copter, right?
What's that? No, I don't want to discuss the details. I want you to understand that if you don't understand the words, you have Google there. Can I get the plastic? Sorry. This here, sorry about that. Just get the garbage. Just, yeah, in your case, you can put it here. I think it's a good spot to put it.
Probably drop it on here. But then
Good. You see? And you are afraid of. What are you afraid of then?
No, because you put her to these. No.
No, they go in the middle.
In the middle, so
And
you
there's
have
three separate water, air.
water, air, and this one has just two levels.
If you guys want to put on that wall, that's fine as well. It's up to you. I mean, I'll leave it up to you. If it's already here, that's fine.
just put it in the middle.
Actually, you know what? Maybe just put it up there. Just put it like
Yeah, maybe use the space here. Maybe use it so we don't mix them up. There's already a bit mixed up.
We don't have to actually stick it on the cover. Here, we'll just have
There might be one missing here. One word.
Oh, we have to put it.
So here's the other thing. As you post them, once you are done, take a picture of your phone, and actually before taking a picture, go to this address and take a picture from the app. Well, it's from the website, because then we can share with everybody else. Everybody else can see it. Okay, so again, let's use that confusion one. So padlet.com/address/confusion. You can click on adding a note. When you add a note, you will have the option to take a photo. So you can take a photo of your set.
This is clear enough.
Yeah.
Now, I think there might be one missing.
One more.
What?
Yeah, there might be one more missing. Yeah, I got the cheap one, Paulo. I got the cheap one. They don't stick well, you know.
Yeah, we have a problem.
Actually, I think It's 18 or 19?
19.
19? I thought it was 18. Oh, thank you. Okay, so again, I would like to see all 1, 2, 3, 4, 5, 6, 7, 8 photos posted here, so we can carry on. So again, go to the address. When you are in the address on your phone, hit plus. When you hit plus, there is a photo option, and then you can snap a photo.
It's not gonna be pretty. There you go.
Cannot see much here. Woo!
Too cheap. Too cheap.
You have to press better. You're the only one falling. Nobody else falling. How come? You can keep going. That's fine. Let's just get it done. You can keep going.
I think or the low. No matter how much you know, there are still so much more.
You delete that. Oh, you got it?
Which one?
Mine?
Yours is this one here, isn't it?
I want to replace it. The better one?
Is that this one? I guess so, isn't it?
I think
Anyone still taking pictures? Okay. Let's take the last pictures before everything falls apart. Because we still need them for a little while. We still have one more thing to do with them. Okay, anybody else there or all good? Okay, so here's what I'm going to do. I'm going to go top to bottom here, or actually bottom to top. Let's see the last. And then I'm just going to ask for that group to defend their view, why they build things like that, you know. And again, there will be some repetition here. That's fine, but let's try to do this. And I'm going to try to zoom in here if I can. Oops. Try to zoom in. Whoa. Okay, so we kind of can see that. It's very blurry. Okay, so let me refresh this. Okay, let me see the very last one. Let's see if I... Yeah, the resolution is not that great here, so it's hard to see. I'm going to try to get one that the resolution is a bit better, and we can talk about it. Okay, this is hard. Okay, this one here seems to be...
That's a name. This one.
That's what? Oh. Okay, so I guess let's take with this one for a second. Then we can open discussion for this one in particular. Who's the group of this one? Back there, you guys? Okay, great. So again, the rationale. Let's start with the first one there. Shape. Why you have organized like this? Just tell me your thinking. You know.
Circle, rectangle, square, and ellipse are kind of shapes, different. That would come under the one parent class shape.
Okay, so basically they are in the same level and they all are children of shape, correct?
Yeah.
Anyone has a different opinion? Anyone? Hmm? Okay. Any opinion different from this one? Any implementation different from this one? What was your implementation, Paulo?
So you can do shape as the main class.
Yeah.
You can have square as another the second parent.
Okay.
And you can have rectangle under square.
Okay.
Also you can have circle and then ellipse under circle.
Understood. Okay. That's another way to put it. Anybody else? Roma, you said that you raise your hand. No. Go ahead.
So it's similar to this, but it's a rectangle equals square, and then you have
Okay, so it was similar to Paul's, but the opposite. But
No, I mean it's the same idea.
well, it's a different one.
No, I'm gonna discuss that.
Who is the second one? The second line in yours. Let's have a look here. Well, if it didn't
I
follow.
didn't do that yet there.
Oh, you didn't do
I did it
it.
like this way. I'm just answering your question.
Oh, you have a
Another
different idea. Okay. But again, it's slightly different from his because in yours, you're mentioning rectangle, circle and square will be first, and then rectangle will be coming from square, and ellipse from circle.
Yeah, I agree. I'm not gonna discuss
No.
shapes, like oval shapes.
I get it. That's fine. Just look at different perspectives here. Actually, I have a different perspective than... Actually, my perspective is similar to his perspective. Because if you think for a second, if you think as a square and a rectangle, who is more specialized?
Square.
A square is more specialized. So, because a square, what is the specialization there? I mean, a rectangle is a square. However, is any square a rectangle? Sorry, let me rephrase that. Any square is a rectangle. However, any rectangle is a square, every rectangle? Not really. So it's a more specialized. So again, this would be fine, but I would go with shape, and then I would go with rectangle, and then I would go with square. Now, let's think about this with circle and ellipse. Who's more specialized, an ellipse or circle?
Circle.
A circle, because a circle has, both axes the same size. An ellipse can have, different sizes for the axis. Okay? You don't agree?
No.
Okay, so again, we agree to disagree. Because here's the thing, there is a restriction for the circle. The circle, what is the restriction? They have to be the same. The ellipse has no restriction. So every circle is an ellipse. However, not every ellipse is a circle. Okay, so that's the idea of the hierarchy here. Okay,
So we have to put the ellipse on top?
we have to, yeah. So I would say that my interpretation of this would be putting the ellipse at the top. Sorry, not at the very top. I mean, it would be shape, and then ellipse, and then circle, and then we have shape, and then rectangle, and then square, because they get more specialized. That's the whole thing about coming downwards. You get more specialized. Going up, you get more generalized. It's more general, and then it's more specific as you go down. Okay. Vertical here, I think that vertical we got pretty much everybody on the same page. Again, I guess that who else had a similar graph as this one here? So Roma, what is the, again, logic here behind this one, the decision here?
Okay, so vehicle is the parent class of land, air, and water, which could be the types of vehicles on land, on air, and on water.
Okay.
So car and bus are the vehicles that run on land. Helicopter and aeroplanes are the air vehicles, and the ship and boat that runs on water.
Awesome. I think that's a good way to put it. Team number 4. Was that the idea here? I mean, because I see a straight line here. So ideally, this would be in the same, car would be in the same line as bus, because bus is not inheriting from car. So the only thing that I would change here a little bit would be to put them like this, to put it in that setup, to keep the same, hierarchies. Okay. Any question about that one, about the vehicle one? I think it's not the easiest one, because I think book might be the one. Who else put it book like this? Again, what's the logic going Roma behind you?
So we have the parent class that is book, and then we have ebook on one hand because ebook is just text on the screen. An audiobook might not necessarily have text at all. It could just be fully audio on the tape or something. And a paper book is actually a physical book.
Mm-hmm.
So that's why we categorize it.
Awesome. Good. Okay. Any question about this so far? Because we have to do 2 more things with this example. We have now to flag, in your opinion, which classes should be concrete and which classes should be abstract. And you're going to be using, I'm full of props today, so what is it? The next prop here. So, we're going to be using red dots to flag it as a concrete class. So you go back to your diagrams. And I need this back, please, because I have more. I need to reuse them. Again, you take one. So you're gonna flag which ones are concrete classes. Again, concrete, we have discussed that. And nobody had questions about it. So that's the time that you can ask as well, okay? I mean, you're not forbidden to ask. So again, flag which ones are concrete class. In your opinion, again, this is a bit subjective, but using your best judgment, which class should be concrete and which ones in green should be abstract classes. What is that? Yeah, so green abstract, red concrete.
Wasn't there is my fault.
Good. Okay. So again, you can just flag on your post-its, and maybe you want to rearrange if you now have different opinions about things.
I'm reading the definition of concrete class. Don't.
Good, because then you can discuss that.
No, I'm still reading the definition here.
Every class that you have built so far in the course, they are all concrete. What's up?
You explained something after that for the addiction circuit hierarchy.
The red ones are concrete classes. The green ones are abstract classes. So again, you just flag.
You explained the concept of that ellipse can be a circle like that. You roll in different.
Oh, I was just saying that an ellipse, all circles are ellipses, but not all ellipses are circles. So again, ideally, I would see that shape, ellipse, circle, shape, rectangle, square. I would see like that.
So we need to rearrange.
You cannot rearrange if you got the same concept in mind. I mean, if you think that, I think that this is not up for discussion. Every square is a rectangle. However, not every rectangle is a square. So again, you'd have square being inheriting from rectangle. Okay? I'm just going to mention the concept again. So concrete classes, you can create objects from those classes. Abstract classes, you cannot create objects from them because they are just a concept. They are not something very tangible. They don't stand on their own.
Air, water, and land would all be abstract classes.
Yeah.
And again, if you are done, just take another, try to take another shoot and then send to that same Padlet that you can share with everyone and discuss there.
So book is white, and book is green, right?
Book is green. Then the rest is red.
What's up?
When I told you that I don't agree, it's because I'm full open mind.
I get it.
No, what I'm trying to say is a circle have a restriction.
Yeah.
But I can tell you an ellipse or whatever have another restriction. It cannot be more taller than what?
An ellipse?
Yeah, ellipse. I can
It
tell
cannot?
Yeah, I can tell you.
Yeah.
As well as you can tell me that a circle have the restriction that everything is like the same
The radius.
So my question is, should we fix that like you explained, or can I keep doing this because both options are fine?
Both interpretations are fine. I'm just trying to exemplify how you go from the higher class, the parent class, which is more general, to more specialized. One thing that we cannot deny is that a circle, it has, both axes the same size. An ellipse, that does not. So a circle, in a way, it's more constrained. There is one extra constraint as compared to the ellipse.
Like an additional.
An extra condition. Not a field so much, because actually they have the same fields. If you think about that, but again, if you think about this, that every circle is an ellipse, but not every ellipse is a circle, that kind of tells you that, oh, you know what? You could definitely implement that horizontally. That's fine. I mean, there would be not a problem. I'm just saying that when you think about inheritance, in my opinion, this is an example of inheritance, of 3 levels of inheritance: the shape, the ellipse, which is a specialized shape.
So in the classes, to simplify, but I think, I mean,
Well, classes is about making sense as well. So again, it is up for interpretation, but I'm here to guide you through those more abstract concepts of what seems to be the most appropriate path. It doesn't mean that there's just this path. It's just that this path is more sound than this other one. That's really it, you know. So again, you can keep that. Yep.
The more abstract class is rectangle and then square, or a square or rectangle?
So the higher the class, the more the probability that they are abstract. Usually, the ones at the very bottom, usually they are concrete classes, because you want. I mean, what's the point of having this 3 if all classes are abstract?
Yes, sir.
Okay.
But sir, the hierarchy is right or wrong? I'm asking that.
So what I would do here, in my opinion, this would be opposite. Because if you think about this, every circle is an ellipse. Sorry, this is okay. This one is okay, but this one is the one that I think that should be switched. Because if you think about this, every circle is an ellipse. However, not every ellipse is a circle. This is good. If you think about this, if you put the same statement, every rectangle is a square, is it? Every rectangle is a square? I can tell that every square is a rectangle.
Every square is a rectangle.
But every rectangle is a square? No, because there are rectangles that they have base different from the height. Square, they have same base, same height. So you're going to be more specialized, you're going to be more generalized as you go up. Okay? Okay, so anyone took a picture of yours that was able to share and we can discuss? Okay, we have one here. Let's have this as an example here. Okay. Let me see if I get it. Okay, so let's discuss with this one here in mind. Let's go with the first set here. Let's go with the shapes. So circle, ellipse, rectangle, square. Okay. Yeah. So let's see this through the shapes. Who had this one here that wants to defend? Come on. It's a good one. You didn't speak yet. So go ahead. Why concrete? Why abstract ones? You said that shape is abstract.
Yeah.
Why?
You can create a form of a shape, but you can't create a shape, because the shape is just like an imaginary thing that is like a theory.
An abstraction.
Yeah.
Makes sense. Makes sense. And then rectangle.
You can create a rectangle or draw a rectangle. Same thing with circle. Same thing with ellipse. Same thing with the square.
Makes sense. Makes sense. So again, shape is something that it's too abstract for us to make it an object. Draw a shape. What's the question that comes after that? What shape? Okay, which shape? So again, you cannot create just out of your head shape. I mean, you can, but again, you're going to be asked: is it a polygon? Maybe it's a general polygon. Maybe it's one of these. Okay, so who had a similar setup here? This is placed as all concrete. Anyone put the box all concrete? Come on. Yeah, so the box one, can it be all concrete. Here it's set as all concrete. Abstract for the book. So again, we have some people that put book as concrete, some people put book as abstract. Defend why you put book as an abstract.
Because if you make book concrete here, it's contextually redundant. Because if you're going to make a book, it's going to be specialized no matter what, rather than just have book. But it feels like, medium, or a source of media or whatever, then you can have a book, maybe TV or whatever. In this scenario, you don't need a book to be concrete because it's going to go under one of the categories anyway. It's like on Wednesday when we did animal and then dog, owl, cat. You don't need an animal, you just go under the categories instead.
Okay. Do you want to defend your position there?
Makes sense.
So change your mind?
Really change your mind because a book is still a book. You can still create a book. Doesn't matter if it's paper, ebook, audiobook, or whatever. It's still it doesn't really need a second part to it for you to create it.
Okay.
If I tell you you can like write a book or create a book, you can just do that. You don't need to ask me what book or what kind of book. It can be standalone. It doesn't
Okay.
require.
I get the arguments. 1 second. Shane?
More on what you said, like, it's about the context. Like, if it was you just had a book class, okay, that's cool, you could use it, but, like, if it's standalone, but since there's other parts to it, then, like, that means that there's more to it, so you're going to have to pick what type of book it is, right? So,
I see.
so in this case,
In this scenario here?
yeah.
Okay. Okay. You would.
Book being concrete is just redundant. It's not necessary. So you just kind of abstract.
Okay. I think that all are valid arguments. I like all of them. I like the argument as well that it's a strong argument that says that in this context, because we are not just throwing like, in the context here, it might make more sense to make book abstract, it might. But again, is it wrong to make it concrete? I don't think so. But again, in this context, it might be. But however, if you are talking about, let's say, teaching tools, that we have books, we have videos, we have papers, we have articles, then that book must be a concrete one. But again, maybe I would go ahead and say that I'm okay with book being concrete or book being abstract. I would tend more, actually when I was putting this together, I was questioning myself about that, and I was thinking that book should be concrete. But again, you guys brought interesting points that in this context, it seems to be more towards the abstract thing. But again, there's no right or wrong position here, just different perspectives, okay? Let's go to the last one. I think that the last one is a little bit more concrete. It's a little bit more concrete. Concrete, talking about concrete. So this one here, who had a similar setup? In the setup there, for those that cannot see, well, I can tell you one thing up front. One thing up front is that we cannot have both. Okay?
Well, half of us said.
Well, maybe you have to rip the circle and put the half. Anyway, it cannot be both. So you either have a concrete one or an abstract one for vehicle. But again, thinking about the way you have placed this, if you have agreed that this is all green, let me see here. Yeah, you could still inherit from a. Yeah, I don't think you can. Actually, that's a good point. I'm not sure. Let me see here. Abstract class can come. I'm not sure if an abstract class can come from a concrete one. I'll check that, because if it cannot, then it would have to be an abstract. But again, having in mind that these are all, let's say, who went for this scenario, all green on the top part, and the lower one all concrete. Anyone that did not defend yet? The four of you? You didn't speak yet. Which setup did you go for? So good. So again, you did that scenario with this in green. What was the rationale there?
You are only going to create like an aeroplane, a helicopter, a car. You are not going to, like the
That's a good argument. So again, we don't create a vehicle. The natural question is, what type of vehicle is that one? And then we have a second level here that, is it an air-based vehicle, a water-based vehicle, or a land vehicle? And then, of course, we have concrete class at the very bottom of it. Any questions there? Any question about this particular setup? I mean, is the concrete abstract class more clear right now? What you guys take? I mean, any different opinions? Anything? All the same? All good? Okay, so let me inspect if it's all the same there. Okay, we have some discussing to do here. Okay. Okay, so let's talk about that. So shapes you put rectangle as concrete, but square as abstract. Come on, what was the rationale there? Yep, go ahead.
It was just a different question, because I remember in last class we had polymorphism.
Yep.
But can you use polymorphism for an abstract class?
Well, so here's the thing. Polymorphism is when you define, an example of polymorphism is when you define, let's say, vehicle. Vehicle, it has a move method. I'll just call it move. Any vehicle will have a move method. We'll have a way to move. Otherwise, it wouldn't be a vehicle. Okay. So you can have a move method, define it, but not created here in the vehicle, because I know that every vehicle will be able to move itself. Now, how they move specifically, it's up to this here to implement that move. But vehicle knows that they can move, but they know how they move. The concrete ones are the ones that know how to move, what they have to do to move. Okay? Does that make sense? Okay? Does it make sense? So again, I'm still waiting for an explanation of those shapes there. Anyone? You may have changed your mind, that's fine. If you change your mind, that's okay. But if you change your mind, just explain what changed in your mind.
So, what warehouse?
Okay, that's fine. If you don't want to mention, that's okay. I get it. But again, the point is that because you can draw a rectangle, it has to be concrete. Because you can draw an ellipse, because you can draw a circle and a square, they all can have their own manifestation concretely. Okay? So that's why I would classify them all as concrete classes. Okay? Also, to finalize, and I'm not going to ask you to go back there, but just to, it should be a blue dot, but let's stop the dots. Let's just go with, let's just discuss that openly. Let's say that we have an interface. We have an interface that is called iSellable. Again, interfaces, don't think about interface so much as a parent-child relationship, even though a class can inherit from an interface. But again, the parent-child thing is not very, go ahead. Go ahead.
So the keys won't start, I can give the keys
Yeah,
afterwards.
20 minutes.
Okay.
Actually, that's a good point. I mean, let's take 5 minutes break. So sometimes I forget to switch classes, take breaks, which don't, so yours do. So take 5 minutes. keep the notes exposed there so I can collect them. Thank you.
With this?
Yeah, you can put everything there. I'll take care of that later.
You need just a note?
Yeah, actually, I need those dots as well, because that's okay. You can just put it. That's fine. That's fine. Just get so I can collect. Okay. Oh, great. Thank you.
Oh, you're saying delete all the...
Yeah, that's another one. Thank you. The markers, you have the markers there as well. Have the marker? Thank you. you. You have the markers in notes, so I can collect them. Thank you. And thank you. Yeah, that's okay. I'll organize later. Thank you. Note to self, buy better sticky notes. Note to self, buy better sticky notes. Buy the expensive ones.
Me too.
That's even more expensive than the Post-it ones. Awesome. I'm glad. Oh, sorry. Try to capture yours there. Just gonna do a zoom. That's okay. I'll try. Sorry. This one here. Thank you. It's okay.
Allowances, but you get more. While sections, tax.
Yeah, this doesn't look as bad now that we drew this.
I'm just gonna take a picture here. It's okay. Sorry.
So I did it book. Remember we made some changes. Should I do? Really? Drop? Okay, apply. And then import.
Well, sorry about that. Okay, so let's wrap this activity. The last point is this one here. Let's not go back to the boards anymore. Let's just talk through this. So we have, let's say that we want to implement one interface called iSellable. Again, when you think about interfaces, you don't see too much of a parent-child relationship. I cannot say that, I don't know, that an ebook is a child of iSellable. Well, technically speaking, you can say that, but when you think conceptually, it's not that clear. I mean, it's very clear in this structure. We have a book, a paper book, e-book, audiobook. However, an iSellable is more of an extension. The hierarchy is all about extending the parents, but interfaces are very much just about extending. In our case, in our interface, we have a method called make sale. So my question would be, what would be the classes that you think, according to our discussions here, would be good candidates to inherit from iSellable? Let me go back here to, so maybe it's hard for ones in the back there, but let's think about, first of all, let's think about the shapes, the shape 3 here. Who would be a good candidate to inherit from iSellable? And again, let's not say that, because then I will be kind of answering. So let's look at the shape structure there. Which one would be a good candidate to implement iSellable? iSellable means I'm selling that. I'm making a sale. iSellable has one method that is called make a sale. If we have, let's flip to book. Let's flip to book for a second. Let's go back to shape. Let's go back to shape. Which one is a good candidate to be to implement, to inherit from iSellable? That's an opinion. Anybody has a different opinion? Any concretes? That's, again, yet another opinion. So any concrete would be the ones at the base. Any different thoughts?
I'd say shape itself.
Shape?
Because anything under shape is basically sellable.
Under, but not itself.
In my opinion, none of this is iSellable. Because you don't go selling a shape. Who buys a shape? So again, I would not implement iSellable for the shapes at all. I wouldn't implement, because again, they're drawings, so I wouldn't implement that there. I don't think that it makes sense in this context here. Okay? However, let's have a look at the book. Thinking in the scenario that we have book as abstract, and then we have paper book, e-book, audiobook.
So e-book, audiobook,
Just book? All 3 in the base? Very opposite answers. Okay, that's one opinion. What is the rationale? That's the rationale of going with the book to implement iSellable. What would be the rationale to implement in the base, in the child classes?
because it's general, like when you buy a book, which book do you want to buy? Like
Okay.
This is an e-book, this is more specific, like something more.
Okay, but you can sell a book and you can sell the 3 at the
I
same
mean
time.
the 3, I mean the 3.
You
like
can
audio,
receive the 3 ones.
e-book and third.
Got it.
You're assuming that book is abstract, so you're not going to make an object out of book anyway. You're just inheriting the iSellable from book.
Okay, so again, we are assuming that book is abstract, and then the base ones, the child ones, base, don't think of like that. I think of the base at the bottom, the base is at the top in our context here, okay? So again, we have two different opinions here. We have one that is at the top, another one that is at the bottom. Who goes for the top one? The one in the top. Who goes for the ones in the bottom? Who does, no matter what I say, he will not go for anything.
Hey, the FBI is here.
I can see that. I'm going, guys. They caught me.
Those guys look like
They caught me.
FBI or-
No, he is the chair, the chair of the course, the tall one. Okay, so line up. Okay, so here's my take. And I think I'm right. I think that you could make book, even if it's abstract, make it implement iSellable. Because we know that we want to sell paper book, we want to sell ebook, we want to sell audiobook. They all share the same method, the same make a sale, however was it called there. Because we are defining it in the book level, they will all inherit that as well. So we are saying that book, even though it's abstract, but it will inherit from iSellable. Now it has a method called make sale. And then that make sale has to be implemented in the concrete classes at the bottom of it. Okay? So again, yes, would it be wrong? I mean, would the code not work if you implement it here? It would work, but here's the thing. You are missing the reusability of that make a sale. All of a sudden, make a sale for each one of these. Well, you could still use that. That would be fine. But again, all of a sudden, you are repeating that this inherits from iSellable, this one, and this one. You are repeating that. You don't need to. You just put it at the parent of them, and they will all be sellable as well. You mentioned something, Shane?
Aren't you gonna have to like override all of them for each of them anyways?
So here's the thing. If this is an abstract class and it inherits from an interface, it can define that make sale as an abstract method here. Here you can define as an abstract. You can override the interface, but define it as abstract because it's still not defined yet. And then you implement concretely in the child classes. Okay? So in that context there, it would be right to put in the children, but I would incline it to go with the solution because they share. See, here's the thing. If all three of them share the same thing, why not put in the parent? If they share it. Okay? So that's the rationale of using less code. Does it make sense? Does it not make sense? Tell me. Paulo, it depends. It depends. Give me the counter argument then.
I'm just giving myself an example about this.
Yep.
We sort information in the Amazon website.
Okay.
So when you want to buy or sell product, basically you are not buying a book, but you're buying In Cold Blood from Truman Capote. That's a specific book. You are going to.
You are buying an instance of book.
Yeah. You're not buying appearance and beauty. You are buying a cream.
Yep.
This is specific product, cream, $10, whatever.
Okay.
So for me, the first level, like book, vehicle, and shape, is a way how we sort this information that is concrete, and what we are selling or buying is the concrete stuff.
Okay.
So that's what I think.
No. And you are agreeing to this.
Yeah.
It's the abstraction on shape, the abstraction on vehicle, the abstraction on book as well. Okay, so you're right. If you can think about categorization as well. You can think about that. The higher you go, the more general category becomes. So again, it makes sense. Now, again, no iSellable here. iSellable here, I would say in the book. And how about in the vehicle, where iSellable would be? If at all. No. Again, we can extrapolate and use kind of the same logic that we use for book,
Okay, I have a question.
Sure.
For this, we cannot sell water and land and air.
We cannot, correct.
So then maybe yes with the boat, ship and car, but what about this middle one? What will we do?
It's really about, go ahead, sorry.
It is very rare you can't sell land, air, and water in that sense, but it's inheriting from vehicles. So it's not talking about just land, air, and water. It's talking about land vehicles, air vehicles, and water vehicles. So all those you can sell.
Actually, that was quite exactly what I was going to say, because you can think of air here as air vehicle, as land vehicle. I mean, it's just about name, You can change this name for water vehicle, land vehicle, and air vehicle, okay? Which in a case, it's a way to classify, a way to differentiate them, because they have, again, different properties, for different terrains or things. So I would agree that iSellable would be in the vehicle. And the abstract classes would inherit that, and it would be sent over to the concrete classes to really implement that make sale. Okay? Great. That's about it. Anything else? I mean, is there any concept here that we have gone through that is still muddy? What is the muddiest thing so far? Anyone can tell me what is the muddiest thing? Yeah, it's still messy. I don't get it. Again, I'm here to. Here's the thing. I've put some exercises on week 10. So we're not going to be starting those exercises now. So feel free to work on them on your own. I'll be providing answers. I'll be providing the videos explaining them. But in a second, we're going to have to go to our quiz. So.
If we have both, like vehicle and air and land and water, all of them are abstract. Would not be easier to don't have the middle one?
Okay.
Just to go.
But here's the thing. Let's think about this. Help me out here. Can anyone see a property or a method that would be common to all water vehicles? I mean, I cannot see right now. I'm just saying. So, but if we think through it, which property could be common to all vehicles? Sorry, to all water vehicles. Well, some will be maybe there's a type. Maybe there's a type of water vehicle. Maybe there is I don't know. Does it run on? It could be. It could be. It's again. I'm not into sailing, but is it a boat that runs on wind, or there's an engine? So the point that I'm trying to make is that there are properties that only water vehicles will have, and those properties can be defined here in the water class.
Okay, but if I will define
Yeah.
it's not an abstract.
No. I'm just defining. I'm not creating. I'm not implementing that. I'm just saying that. Again, it draws a blank when I think about water stuff. So, can float? Well, it could be. I mean, we are talking about submarines as well. Who knows? Well, it can go under. It can go underwater. The point is that it's not implemented here, but it's a property that is only available to all water vehicles. So the point is that there are properties in the water vehicles that are common to all of them. It should be defined here. Because then you can do things like you can go through a loop of water vehicles, and you can say, you can test, can it dive or can it go underwater? Yes or no. The point is that there will be specific properties that are common to all air. An air vehicle, what is it? How many engines does it have, or how high can it go? That could be it. No, how high can it go? So again, it would be defined here, and because a helicopter and airplane they inherited from air vehicle, they all have that height or whatever it is, that altitude. The altitude that it can go. So it's all about reusability. Land as well. How fast you can do with all of them. Okay, sure. Go ahead.
Can I do the quiz?
You can. Yeah.
He's gonna tell me.
What?
He's gonna tell me when you start the quiz.
Okay. Okay, so that's about it. Again, just want to close this topic here. And of course, if you still have questions, if you still have confusions, I mean, well, we are using confusion Padlet, but that's okay. Again, anybody else wants to ask anything about this? Was it valid? Was it a valid exercise? Does it help to clarify a little bit of more? Okay, great. So before we go to our quiz, let's do this. Still have a few things to. So again, exercise programming exercise 09 is available on Centennial. It's all about. It is all about polymorphism, abstraction, interfaces. You can see them on week. See, here it is on week 10 in program exercise 9. The other thing I want to mention is assignment 4 has been released, and I just want to go over that for 5 minutes. So if you go to assignments, there are a few files related to assignment 4. So this is the PDF document. This is a UML. In this PDF, there is a diagram, but the diagram is very small, so you cannot see it very well. This one here is a full page blown up of the UML diagram that is available in the document. And then, in the last file, there is a piece of code that you're going to copy that code, and you're going to paste that inside of your main method, and you're going to run that. Hopefully, if you implement it correctly, I'm just going to open it up. So don't get concerned about the extent of this. It's just long, but it's not very deep, okay? So again, it's just a lot, but it's the last assignment, yes, it is. The last assignment, and it's due in 2 weeks. Okay? Because if I make it due in 3 weeks, we can change that if you want. However, in 3 weeks, exactly our last test. Yeah, I think it will be the week of the test. So, again.
Because our test must be the 11th.
What is that? The test, yeah, that's fine. That's true. That's true. Because Friday is a holiday. So do we still have 3 weeks or 2 weeks before the test? Anyway, right now, the due date for this is in 2 weeks. Because you're going to see that it's not such a big deal, even though diagram may say slightly different. But let me explain what the diagram is. So this assignment will basically draw a head. It's a very graphical, very visual assignment. At the end of it, you're going to get this face. Because you're going to be dealing with lines, arcs, rectangles, ellipses. You're going to be working with that. So at the end, the code that I provided in the file will call your classes and will produce this output. Okay? And it will save as a file. Then, the classes, let me just blow this up a little bit more. Let's see if I can. So let me just talk a little bit about this diagram here. So you have two interfaces, very simple interfaces, just one single method on each one of the interfaces. So we have two interfaces to implement. You have a class called primitive, which has some basic properties. All of that is defined there in the document. You just follow, this method has a parameter called color. The type of color is called color. So you just type in that. And there's a little bit of implementation, but not much. It's really about getting to know more about inheritance, interfaces, and polymorphism. So again, all the methods are defined already. So you have a primitive class, and then you can draw a rectangle, you can draw an ellipse, or you can draw an arc. Here there's a new representation that shows, this one here, it inherits as well from iDrawable, it inherits from iWritable. So it shows here, this one here only inherits from iDrawable. This one here iDrawable, and iWritable. And then we have two that are more outside, standalone. They don't inherit from primitive. It's drawing a Bezier, which is basically a kind of an arc that it has a bit of an angle. And then drawable line. So again, the classes that you're going to be using to produce that face, these are the classes. So with a class that draws a rectangle, that draws an ellipse, draws an arc, draws a Bezier, draws a line, you're going to call those classes, and the result will be that beautiful face there. Okay? And that's it. That's our last assignment. There's one, just one second. There is one test case that you have to create. Very, very simple test using the testing techniques that we have discussed before, because on the rectangle, it has an area method. The ellipse, it has an area method. So you're just going to write two test methods to test if the area of this class and the area of this one here, if they are producing the correct results. So again, you're going to use the steps that we have discussed about testing to test these two methods. Everything is explained in the document. Again, document is just detailed. It's not really complex. It's just very detailed that if you follow from top to bottom, there's no way to go wrong. Because at the end of the day, when you run the application, you're going to see the output. The output is a file that should show that face. If it's not showing the face, well, it's not right yet. So let's go back there and see what needs to be adjusted. Shane, you had something.
So there's only one property for the whole thing?
One property to the whole thing. I mean,
Like,
giving some more here.
I only see the primitive thing has properties.
Oh, properties. Good point. Good point. Good point. So, let me see here. Actually, property-wise, they don't have properties. These are all fields. These are all fields, and yeah. See, they all have lowercase. None of them has uppercase, which usually indicates a property. So again, you don't have properties here. You just have fields. Again, one thing to keep in mind is, are those fields public, private, or protected? Again, that's one of the things that you have to figure out. Well, actually, it's also saying that here. Okay, you don't even need to figure out that, because this is a representation of a protected field. So again, follow the diagram, follow the steps in the document, and again, within about 8 hours, you can get through that. I'm joking. Of course I'm joking. Of course I'm joking. It's a group thing, so again, you have to rejoin the groups via Centennial. So do it on groups. Again, it's just to get us through the finish line here. We're very close. Okay? Anyway, talking about finish line.
When you said you're talking about the 8 hours, you mean it's longer, right?
Yes, right. Anyway, I don't know if you want to get some water or whatever before the quiz. That's the right line. Let me just activate the quiz here, and we can get through with it.